Hello students, hope you are all at home having good time, and we know these days we are not going to school, right? And you people are feeling bored, might be. So our administration have came up with a very good idea to approach you guys, that is online education. So here I am today, Mr. Binoy Chhetri, to teach the students of class 7 the second chapter, that is force and pressure, and later on we'll come to know about motion. So in this chapter, the first term we will learn about is rest. Now what do we mean by rest? Rest means a body is said to be at rest when it does not change its position with time with respect to its surroundings. That means when a body, when a body does not change its position with time or with respect to its surroundings. For example, house, tree, whatever we see outside, that is the car which is standing still, which is not moving, your table, your chair, those all objects are at rest. Now let me write the examples. Example of rest. uh, Trees, house, table, chair, etc. These are the examples of rest. That means trees, house, table, chair, these objects, they don't move, they don't change their position with respect to time or with respect to their surroundings. Now motion. Rest we have discussed. Now motion means a body is said to be in motion when it changes its position with time with respect to its surrounding. That means when a body changes its position with time or with its surrounding, with respect to its surrounding, then that body is said to be in motion. Now example of motion. Example of motion are like this: people walking. Second one, birds flying. Insects crawling, etc. In this case, what happens? The people, they change their position with time or with their surroundings. Similarly, when a bird is flying in the sky, he or she or it change its position with time. And insects also, while they crawl, they also change their position with surroundings or with respect to time. Now while we are discussing about rest and motion, we come across one word, that is reference or with respect to. What happens when you discuss the state of something? Suppose rest. We discuss the state of an object that is at rest with respect to another object, or we say an object is in motion with respect to another object. That means rest and motion are relative terms. Relative terms means they are interlinked, they are related to each other. Now let me example is like this. Suppose you are going in train. You are inside a train and one passenger is sitting beside you. This is train. You are traveling in a train and another passenger or co-passenger sitting beside you. What happens now? You are at rest with respect to that man or woman, whoever is sitting beside you. Now at same time, the third person who is in, suppose, platform. This is platform. Suppose this is platform and one man is standing here. You are at rest with respect to this man, but you are in motion with respect to this, because it says that you are traveling when you notice. That means simultaneously you can say that there is rest also, there is motion also occurring at same time. That means you are at rest to one set of object and you are in motion to another set of object. Okay, in physics we come across different kinds of topics, okay, different kinds of terms like scalar and vector quantities. This quantity is said as, for example, let me give an example: speed, distance, etc. Okay, this quantity are scalar quantity. That means scalar quantity means it needs only magnitude to measure. Okay, that means the quantity which require only magnitude to measure is called scalar quantity. Example I have given already: speed and distance. And similarly, vector quantities means the quantities which require both direction and magnitude to measure itself. Okay, that is vector quantity. Example: displacement, force, acceleration, etc. Okay, these terms they require both magnitude as well as direction to measure itself. Now, scalar quantity called distance and vector quantity called displacement. Let me discuss something about these two quantities. Suppose a man is moving from this point, A point, to B point. Let the distance be 5 km. And again he moved to C point. Let the distance be 7 km. So the total distance traveled by a man, okay, will be equal to 5 plus 7, that is 12 km. And what about displacement? Displacement means the shortest distance between the initial point and final point. That means that is given by this part. So what happens? Displacement is given by root over 5 square plus 7 square. Okay, so displacement is given by root over 5 square, that is 25, plus 7 square, that is 49. That is given by 74 root over. Okay, the figure which I drawn previously, in that figure the distance was 12 km and the displacement was 74 km, root over 74 km. So this was for today. Next we will do in next class. Thank you.